make a video on how to use dscan. The previous video I made didn't have sound, and I thought it would be better to include the sound to explain this a little bit better. So dscan is a wrapper around Nmap. It makes it possible for a group of people to scan an internal network, for example, and distribute the targets across those agents, several agents actually. We have the tool is published on GitHub. It's very recent. I've included a short how-to, but there are several features that are not as transparent in the documentation by this time. So another reason to make this video. So the first command we have here is configuration and the certificate generation, because it's using SSL. The second is the server mode right here, and the last two are the agents. So these two will ask for targets for the second one. The slash name, the dash name is the name of the project where it's going to store the configuration, the certificate, and the reports. And then we have the bind address and the server address and the targets file, as well as the configuration file right here. These two are generated by the first command. It can be changed. So for this demonstration, I'll be using two machines. Virtual machines is running right there, and the desktop host. I've already updated the repository, so I'll start by installing, make a local installation of the project. Okay, by this time you should have this, and this time this should work. Okay. So with this out of the way, we can proceed. So try the same on this side. So this time already running as root, so no need to do that. Hopefully we'll go. Okay, and we're off. Okay, so I'll have to do the same right here. So so we have here a folder, it's an empty folder. I have the targets file. It's like this because we'll see how the application treats the IP address lists. So this first command will prepare the environment we're trying to set up. So it generated a private key and a certificate, which you should have right here inside the serve demo directory, which was the name that we were given. Then inside we have two configuration files, the dscan. It's an extended configuration, generic configuration parser from Python. It is using interpolation to avoid repeating same things. Some of these flags can be tweaked, the ports, you can change these. The discovery process, you can increase this number as much as you can. The names in here shouldn't be the equal for obvious reasons, but the only name that, if you want to include the discovery process, that needs to have exactly the same name as this one. The others, you can change the name it whatever you want. The rest, it's a fairly simple. This is the stats directory, which is the run folder where the running process will keep its state. So the first file used by the discovery process is the targets file, which is going to be generated based on a txt that you're going to pass through the input. Then the discovery process generates a live target. The trace file is a resume file, so this has the ability to resume if by any chance you leave it running and it crashes or you have to leave. It resumes from the point where it was. Then we have the certification configuration features, the algorithms used to encrypt the tunnel or the connection between the agents and the server, and the certificate file. Then we have the agents configuration file. It's fairly simple. We need the certificate because we're using it to authenticate the clients, not a real certificate authentication, but we're sharing a secret and using the certificate to make some weird authentication for the purpose of what this is. I thought it would be sufficient. Then we have the certificate host name and the reports directory. So this is pretty much it. So the first step would be to transfer these files to this folder right here. So SCP agent and certificate to okay, probably, yeah, create this folder as root. Okay, so if we go here, because we're running a dscan, so where's my head, man? As I was saying, since we're going to use the dscan, it's important to run as root setup and testing the environment. I forgot to change the permissions of the folder. It's no big deal. Okay. Now this is Nmap, so we'll change this. Create a folder. Move the agent and certificate into Nmap. List the contents of Nmap. So it's right there. It's ready. Now I'll do the same for this host right here. Change it to root. .47 demo. Clumsy typing there. Okay, MV agent certificate KL64. Okay, everything's ready. Let's go. So with this on, we'll be ready to start the process. So the first step that the server will be making is to turn this file into a CEDAR format. If there, in cases where there are not enough sequential IP addresses to generate a CEDAR format, it tries to make a glob format, which is something like from 1 to 9, or from 1 to 5, or from 100 to 110, or 103. So you don't get, you probably got already. So this is to, the objective of this is to keep the number of cluster IP addresses in the biggest number as possible, without going further from /24, which it's my idea of optimized scan. So if you by any chance set up with a /8 or /16, it will create a division of that through /24s to optimize the scan. So run the server. Okay. Okay. So we have 6 stages. Number of pending tasks. We'll see what this is in a bit. This is total completion. This is the same but as stage-wise. So the number of finished targets per stage, the number of targets the stage has, the name of the stage, and the percentage completion. Right now, this percentage completion, it's not as synchronous as it should be, so the next improvement reach touch this space. Then we have the list of the agents connected, which is currently none of them are connected, so I'll try to establish a connection right now. We'll start by KL64. Okay, so this one is running the discovery, it's finished already, and it's going over the scans. This one hopefully will join in, and you see they're scanning, going over the targets. Now, if we go into the run folder, and into the server, we have here what I was talking about. So as scans finish, the agents transfer the reports in XML format. Inside here you have a backup of the scans in XML format and Nmap format. Okay. Since the agent is not aware of the stage, when the IP addresses repeat themselves in the report's name, they prepend a number like this. Then they're transferred here and the process proceeds. Now, as I was saying, when an agent closes, the number of pending tasks increases. So this means that the next time an agent finishes a scan, this task will be given away. This. So this allows for a scan to run smoothly, even if one of the agents falls or gets disconnected somehow. It also allows, I'm going to interrupt this, for example, right here, for this to happen. Okay, number of pending tasks too. Need to ask for this one to start, for this one to start, and everything resumes as it was. So it's a nice feature to have when you're scanning huge networks and want to leave something running in the background. So it's more or less this. Then we have the rest of the folder. This is the reports, and this is the runtime folder. Now the current.trace is a serialization of the context class and the state of it. Then we have the live targets folder. In this case, most of it is /32s because my network is quite small. Then we have the targets of work, which was a /24. As I said, it tries to cluster IP addresses, sequential IP addresses in CEDAR or glob format. 31 +1. And here we can follow the actions of the agent. So somehow something weird happens and want to know what's really going to happen, what's underneath. When the scan finishes, the server notifies the agents and they all disconnect, and the process is finished. If you have any contributions or questions about the inner workings of the scan, you can go through the code on GitHub or try to reach me. Until then, happy scans.